The third feature of the atmosphere is its role in transmitting moisture, or what we call precipitation.
Rule number 5 in explaining atmospheric behavior is that warm air absorbs more moisture or water vapor than cold air. This is clear to anyone who's hung their clothes out to dry on a summer day. In summer, the air is warm, and so it can absorb moisture from the wet clothes. The moisture suspended in the clothes evaporates or turns into water vapor that is absorbed by the warm air. This dries the clothes. It wouldn't work to hang these clothes out in winter because the cold winter wind could not absorb the moisture from the clothes and the clothes would not dry out. Conversely, consider also in summer when you're sitting on the back porch drinking a glass of iced tea. You'll notice that water forms on the outside of the glass. Why is this the case? Well, the warm summer air is saturated with water because it has absorbed moisture from the environment. This warm air comes in contact with the cold glass of iced tea, and when it does, the air surrounding the glass cools, and therefore the moisture in the air condenses because the cold air cannot absorb all of its moisture. As this water vapor condenses out of the warm summer air, it forms beads on the outside of the glass. Note, the water on the outside of the glass comes from the surrounding air, not from inside the glass. Now, how does this fact of difference in moisture content of warm and cold air affect the atmosphere on the Earth? Let's go back to our slide of the Hadley cell. Again, we see the Earth on its side. The axis is horizontal and the equator is pointing up and the poles are at left and right. You recall from our previous discussion that at the equator, warm, light air forms a low pressure zone and the air rises near the equator. Previously, we explained that warm air rises because of its lighter weight. Now let's add to this story the fact that the rising warm air is also wet. It is full of moisture that has been absorbed from the surface of the Earth, including the oceans, because warm air absorbs moisture from its environment. As this light, warm air rises, however, it gets further from the Earth, and therefore it cools. The cold air cannot hold all of the moisture that was originally added to it when it was warm air near the surface of the Earth, so the moisture in the air condenses and falls as rain near the equator. Not surprisingly, we will find that around the globe, the land near the equator is exceptionally wet. Now also remember when we discussed the Hadley cell, that as this air from near the equator rises, gets further from the Earth, it therefore gets colder. So as it gets colder, it's going to condense the moisture in it, which will fall as rain. And then that air is pushed up and out toward the poles. It gets colder and colder, and therefore can absorb less and less moisture, and therefore more and more of that moisture is wrung out of the air in the form of rain. Finally, that cold, heavy, dry air reaches 30 degrees latitude, north and south. At this point, you'll recall, it forms a very high pressure zone. That cold, heavy air pushes back toward the Earth, forming the subtropical high. But as it does so, it is very dry air. It has lost all its moisture, and as it reaches the surface of the Earth, it warms up. Well, what does warm, dry air want to do? It wants to absorb the moisture from its environment. So not surprisingly, at 30 degrees north and 30 degrees south latitude, where we see this high pressure zone, we find extremely dry climates or deserts. For the evidence of this, let's look at a map that shows average annual precipitation around the globe. What this slide shows is that near the equator, in the Amazon River Basin, in Central Africa, and in Southeast Asia, it is exceedingly wet, shown here by the dark blue color. Whereas when we move to 30 degrees north latitude, we find the Sahara Desert, the Middle East, and over on the other side of the Atlantic Ocean, the American Southwest, Southern California, Arizona, New Mexico, West Texas, all exceedingly dry areas formed by the subtropical high. Similarly, in the southern hemisphere, we notice the deserts of Chile, in South Africa, the Kalahari Desert, and in Australia, the Great Outback. Finally, to summarize what we've seen in these discussions of global atmosphere, remember that we've said that there were 5 basic rules governing the atmosphere. That the sun heats the earth unequally. Secondly, that the sun heats the earth and the earth heats the air, therefore also unequally. Third, that warm air is lighter than cold air, which sets the air in motion in this Hadley cycle, or north-south, south-to-north direction. Fourth, that the Coriolis force, by which the spin or rotation of the earth deflects air to the right or the left, produces easterly and westerly bands of wind around the globe. And finally, that warm air absorbs more moisture than cold air, producing bands of exceedingly wet climate where there is warm air rising, and exceedingly dry climate where there is cold, heavy air descending.